Hello, everyone, and welcome to Industry 4.0, How to Make It Work for Your Manufacturing Business. I'm Selena Cochran, your host for today's webinar, and I would just want to extend a hearty thank you for joining us today. As the webinar progresses, please feel free to use the question section to the right of this presentation to drop any questions that you'd like to ask. Any IT-related issues or questions or concerns that you're experiencing, please feel free to drop those in the chat section. I'll be monitoring those closely and I'm happy to help out with any issues you're experiencing. As a reminder, access to a replay of today's webinar will be available for all registrants and attendees. An email with 24/7 on-demand access will be sent immediately after the webinar. A separate email with a copy of today's presentation will be provided to you as well. And now, without any further ado, I would like to turn the webinar over to my colleagues, Drs. Mike Thurston and Mark Kristofik.
Good morning, everyone. The webinar today is being presented by the Center of Excellence in Advanced and Sustainable Manufacturing, which is supported by Empire State Development's Division of Science, Technology, and Innovation. The goal of our center is to help manufacturers with technology development and adoption to help them improve their competitiveness. Industry 4.0 is one of the areas that we're looking to engage with companies on to support both company planning and also implementation. So my name is, as Selena said, is Mike Thurston. I'm the director of the Center of Excellence. I've been at RIT working in applied manufacturing research now for 18 years, and prior to that, I worked in the automotive industry in product development.
And I'm Mark Kristofik. I've got 20 years of industry experience in manufacturing, starting from a manufacturing engineer all the way up to operations manager, where I had responsibility for manufacturing, supply chain, and engineering. And I've been at RIT for the last 5 years.
So as an outline to the webinar today, first we'll do a brief overview of Industry 4.0. Then we'll go into some of the key technologies that are part of Industry 4.0. Some of the technologies are still evolving, but many are already available on the market. After that, we'll look at Industry 4.0 benefits in the context of a couple of industry case studies. And then we'll talk about how you can get started working towards Industry 4.0 implementation. It's important to start developing the capabilities and competencies, even if you start slow, as it's likely that your competitors are already started down this road. And ultimately, those that are ahead in this area are going to have a competitive advantage in the future. The idea of Industry 4.0 was originally developed in Germany in the 2011 to 2013 timeframe. It was recognized at that time that there were a number of technologies that were being developed and also hitting the market that represented potential for disruption in the manufacturing industry. The 4.0 in Industry 4.0 stands for the fourth industrial revolution, and it's anticipated to have a similarly large impact as the last three industrial revolutions that you can see on the page here. In Industry 3.0, automation and computing power were added to manufacturing in a hard-coded kind of way. Industry 4.0 represents integration of growing capabilities in computation and intelligence with the physical manufacturing system. So bringing those two things together, and then also integrating that with information connectivity and advanced analysis to drive improved decision-making across the enterprise. This slide shows a selection of technologies listed on the right, and we'll come back to these later in more detail. When integrated together, these technologies have potential to transform the business operation areas shown on the pie chart. Improving customer value is a key goal and outcome of Industry 4.0, and also from a personnel standpoint, people, your people in your operation, in your manufacturing technologies, and advancing those are really key to achieving that higher customer value. So at a very high level, the benefits include improved decision making, improved resource productivity and efficiency, including labor and material efficiency, flexibility and agility in your processes, customer responsiveness, so those get to improved reduced customer lead time, and then also value through new services that you can implement. You'll see most of these benefits show up later in industry case studies that we're going to talk about. These benefits can be related both to your product design and also your manufacturing process. And Industry 4.0, as generally defined, includes both changes to how your products are designed and also supported in the field, and also how your manufacturing process operates. Today, we're going to focus more on the core manufacturing side of Industry 4.0. Like continuous improvement, Industry 4.0 isn't really a state to be achieved. It's really a mindset and a journey towards more effective use of information and technology. This chart illustrates a path towards Industry 4.0 maturity as you move from the left to the right. The gray bars on the left represent Industry 3.0 attributes of computerization and connectivity. In Industry 4.0, we're trying to use improved information and technology to generate, first of all, better visibility into the real-time state of processes. Second, the transparency bar represents understanding of the root causes of process defects or inefficiency. So first visibility, then understanding. The next step is predicting or understanding ahead of time what will happen. For example, planning for maintenance before a failure occurs or a machine goes down. And the last stage shown, adaptability, is driven by intelligent systems that can take or at least suggest action automatically, allowing for process corrections to be done on the fly without a human in the loop. This graph shows results of a study by Boston Consulting Group that was conducted in 2016. Over 300 mid-sized U.S. companies were surveyed. The survey showed that while not too many had fully implemented Industry 4.0 concepts, almost 60% of the companies have already started working in that direction. The survey also surveyed a similar number of German companies and showed that they were a bit ahead of the U.S. cohort, where 80% of the German companies were already engaged in working towards Industry 4.0 implementation. We hope that the webinar today will give you some ideas on how to move Industry 4.0 forward in your operation.
Now we're going to take a look at some of the technologies that are involved in Industry 4.0. There's a wide variety of terms that are used to describe capabilities that fall under Industry 4.0. Digital manufacturing and smart manufacturing are two of those. There's no widely accepted definition yet for these, but in general, digital manufacturing refers to the digital thread of data about the product, from design to manufacturing to how it's being used by customers and even service for the product. Smart manufacturing generally refers to managing the technical and business processes associated with the manufacturing process. Both fall within the broader description of Industry 4.0 in our discussion today. Now we're going to take a look at a few videos that demonstrate smart manufacturing capability. I would say they are Industry 4.0 light. They generally give a sense of how these technologies can be implemented with existing equipment or systems. In this video, a part is set up in a CNC mill. For demonstration purposes, the part orientation is adjusted to simulate natural variation. The variation may not be visually detectable, and if it was observed, the part would need to be reset anyways. In this smart manufacturing process, a probe comes down, to effectively read the part orientation. It verifies that it is the correct part it's expecting and determines what the orientation of that part is. This information can be related to the expected ideal orientation the machine code is expecting. The machine instructions can be automatically updated to account for the variation. As you can see, the machine now comes down and does the milling deburring operation on this part. This is a relatively simple example, but you can imagine this type of capability more broadly being applied. Even for a case where you were able to identify tool wear that was happening on a part after, say, 500 or 1,000 cycles, maybe the machine would automatically be adapted to change speeds so that you extend tool life wear. In this next video, it shows adaptive robotics technology. It's a very challenging task. The robot arm is used to place a camshaft into an engine block. The exact orientation in which the robot picks up the camshaft might not be the same every time. Likewise, the position of the other moving parts inside the engine block may also vary between engine blocks that it's trying to do this task with. To allow for adaptive capability, the robot is equipped with force response technology. It attempts to place the component, applying a defined amount of force, then measures the resistance it encounters. The robot uses this information to adjust its approach until it finds the correct orientation for insertion. I never thought that I would see this adaptability in robots in my lifetime, but here it is. The last video showed an example of flexible and adaptive robotics. As the technology advances, robot platforms and the grippers and end effectors that are used are becoming more robust. You've also probably heard of cobots or collaborative robots. They are designed to safely work together with humans side by side. Robots and cobots are also becoming more customizable. Greater ease of changing from task to task. Ease of programming is an important component of this. Now there's point-and-click programming where the robot can formulate the detailed task instructions in the detailed instruction set itself. There's also increasing autonomy in action of there's also increasing autonomy in action of robots being able to reason in complex environments and generate behavior that it's not hard-coded. In a sense, think of self-driving cars. The explosion of intelligent and connected devices that are available for home use is part of the Internet of Things. The drivers of consumer technology are also driving manufacturing technology, and that is known as the Industrial Internet of Things. Low-cost sensors, embedded processors, and software make it easier to collect data for improved visibility of your manufacturing process. A major driver of Industry 4.0 is collecting more and better data, but most importantly, making better use of that data. Big data technologies and cloud computing provide the means to manage these large data sets. The cloud is a set of data storage and application management tools that are increasingly available on a timeshare basis from suppliers on the web, such as Amazon and Microsoft. Increased availability of cloud-based manufacturing software. In some cases, using the cloud provides more cost-effective ways to establish a business system like an ERP system or enterprise resource planning system, or access to applications that you don't frequently use but want to use on a pay-per-use basis. Data analytics refers to tools that can be used to extract information that's buried in the data, or to model process characteristics based on data that allows for process optimization or quality improvement. There are many high-powered open source tools to support development, and also a rapidly growing number of packaged software tools that provide process visibility and increasing levels of sophisticated analytics. Artificial intelligence technologies are less prevalent today, but are growing at a fast rate. They allow human-like reasoning capabilities for software-driven systems. Connectivity and integration streamlines business. The vision of Industry 4.0 drives seamless integration of data, vertically from the machine level to the manufacturing plant level and business processes, and then horizontally from suppliers to the plant and to customers. Think of having a unified dashboard that allows viewing of performance data at any level of the organization. The platform may consist of a variety of software tools that are under the hood, such as your ERP system or a manufacturing execution system or different data analytics tools. But all of that would not be apparent to the user using that dashboard. The unified platform would also suggest actions that should be taken to improve system performance out on the shop floor, for example. Connecting different pieces along the value chain helps you make decisions at each level and understand the interactions between those decisions. The next section will describe Industry 4.0 benefits in the context of several industry case studies. The first example is of an augmented reality, using augmented reality in electronic work instructions. This is a project that we did with a small company in New York State to evaluate the technology. Without going into all the limitations of paper-based work instructions, the new system we developed integrates with the company's ERP system and their computer-aided design CAD system to present all the information a person would need to perform the assembly, test, and packaging operation for a given part assembly. Essentially, an operator can use a tablet or other devices such as wearable smart glasses and invoke instruction videos, overlay CAD models, video conference with an engineer to ask a question, and allow information to be automatically uploaded to the ERP system so that you avoid having to key data into the ERP system. Getting information to and from the manufacturing worker on technology that they are familiar with, such as smartphones, is a practice that is being increasingly adopted. The other sense too here is often we see reduced task times by 50 to 90% when these types of electronic work instructions are used over paper-based systems. The next example is a logistics company, NAP. They utilize a vision system to help employees locate and pick items more quickly. In the picture that's shown there, you can see that the person has wearables on that help with the wiring diagram for an electronic control panel. Next example is for Nova Chemicals in Calgary. A process, chemical facility has a tough time dealing with getting maintenance done. They were able to utilize SAP, which is their ERP system, to implement advanced analytics and improve maintenance tracking and scheduling. So they achieved maintenance schedule compliance improved by 20%, 22%, and their unplanned outages or emergency maintenance, those surprise things, reduced by 47%. Black & Decker implemented an Aero Scout Enterprise visibility system and used Wi-Fi tags to provide real-time tracking of material flows and process efficiency within their plant. The visibility that they were able to achieve allowed for continuous feedback and improved process optimization. We saw gains in labor efficiency, and also their first-time defects through were reduced as well. Kaiser is an industrial compressor manufacturer, and they had a goal to reduce downtime for customers. They implemented an Internet of They implemented Internet of Things to collect key data, and they used it with predictive analytics to warn of potential equipment problems so that customers knew when they needed to do maintenance or were going to run into some problems. As a result of their success, they implemented an Air-as-a-Service business model, which ended up being a win-win for both Kaiser and for their customers. This next example from Rolled is a more holistic top-to-bottom implementation of Industry 4.0 technologies. From Internet of Things to data analytics and to various information display technologies designed to engage staff in the real-time working of the factory. This slide shows some of the different types of displays that they used, including machine status, factory key performance indicators, or KPIs, process warnings that could be sent to the operator or to the manager. The software to implement this type of factory instant messaging is available today and relatively low cost. Some of the metrics that they were able to see for their overall equipment effectiveness, particularly their serial manufacturing plant, improved by 7.1%. And then you can see the door lock assembly line, that improved by 9.6%, their injection molding line 4%, but overall the plant achieved 7.1% in improved OEE.
So that was a quick review of some of the benefits that other companies have seen with Industry 4.0. The next section is going to give some suggestions on how to get started yourself. So these are a few high-level tips. Most important is not being driven by the technology side, but by business value. Once you understand the business value, then you can look for technology solutions to help achieve that value. For example, if you have a line that occasionally goes out of control, causing scrap and downtime, but haven't been able to isolate the root cause, adding additional data collection and some advanced analytics or machine learning methods may be able to provide advanced warning of the problem so that it can be corrected before you have unscheduled downtime. The second tip is to also focus on developing a broader vision of business opportunity at a higher level that can drive longer term planning and goals. For example, if there is an opportunity to increase sales in your business by reducing lead time, you could look at Industry 4.0 technologies to work on lead time reduction to achieve that benefit. So the kind of things that Industry 4.0 might help with is automation of business processes and information flow, or improved scheduling to help reduce delays throughout the process. Again, just one example there. Finally, transformation does take time, and it's important to start developing the internal skills and mindset for this transformation. So how can you go about that? You can start with smaller projects that have a clear business impact and relatively low risk. So you try to identify something with a higher opportunity for success so that you kind of have a positive experience across the operation. And as you're working on this initial pilot, that'll help with developing the internal capabilities and also understanding maybe where you need some different capabilities to bring in from outside. And also, by going through this process, you can develop both management and workforce support for broader Industry 4.0 initiatives. Companies that are currently implementing Industry 4.0 are seeing value in these, these four areas. Most of these we've talked about in some detail earlier. I'd like to talk a little bit more about the first two. So in quality, yield, and throughput operation, by generating more real-time data on the state of your processes, you can use that with advanced analytics methods to better understand the root cause of quality, yield, and throughput issues. And also, then you can use that also, the same data, to better track performance and build visibility into areas with the greatest potential for improvement. And this can help you to accelerate existing continuous improvement processes and also help again to drive that digital and data-driven mindset that helps you develop the capabilities towards Industry 4.0. Readiness assessment can also be useful to identify current gaps and areas of opportunity in your operation, and also to drive your Industry 4.0 strategy. This is an outline of the assessment process that we're working on developing with the Digital Manufacturing Institute. That will also include a self-assessment workshop that will probably be scheduled later this year. The small numbers in the figure here represent 16 different elements of the assessment process, which cover all of the key areas of your manufacturing enterprise. So while the self-assessment training doesn't exist yet, there is a process available, and we would like to start working with companies to get this moving in New York State. So we're looking for a pilot company or two to start rolling out this assessment process. So kind of in summary, you've seen that companies are already beginning to implement elements of Industry 4.0, and also that many of the needed technologies are available in product form today. The goal of our center is to help companies improve their competitiveness through implementing technologies such as Industry 4.0 or other advanced manufacturing technologies. So here are a few ways that we could potentially collaborate with your manufacturing business. We can get together with your staff to discuss some of the challenges you have, so connecting your technical people with our technical experts, or just to have a more detailed discussion of a particular technology that you're interested in. We can also help with product or technology reviews or comparisons. And we can also help you work through the readiness or assessment that we talked about, or also looking through your operation to look for the opportunity areas that may be potentials for an Industry 4.0 implementation. And then when the opportunity is identified, we can help you evaluate and also develop and implement the technology to address a particular opportunity. So that's the end of the webinar. I hope that you reach out to us if you think that there may be a way for us to help you get started on your Industry 4.0 journey. And we'll be now starting questions.
So thank you, Mark and Mike, for such a great presentation. If anyone has any questions, please drop them in the question section, and we're just going to answer them as they come in. Here's one now. This question is, what is the difference between Industry 4.0 and lean manufacturing? Mark or Mike?
Lean manufacturing is really about taking waste out of your operations and moving from, let's say, batch processing to a one-piece flow, so you can highlight the waste that's there and streamline your operations so that you don't queue up a lot of defects and things like that. Industry 4.0, it allows you to collect information that supports your lean manufacturing journey. I was at a conference recently, and one of the presenters talked about lean manufacturing in Industry 4.0, and he said that once we started to pull information using Industry 4.0, we were able to kind of put our lean manufacturing program on steroids, meaning they were able to now see data that they couldn't get before with the lean manufacturing that they could act on to drive process improvement, improve quality yields, and just make overall improvements in their operation.
Thanks, Mark. We have another question. Let's see. This one is, if technologies are rapidly evolving, why should I get in now? Should I wait until the technology is more developed? Mike, you want to?
So we talked before about being driven by value in your operation. So I would say, first of all, if you're going to invest in some technology, you need to understand what the potential return on investment is. And because there are many technologies already on the market, there are some commercial solutions to commercial technologies that can help you achieve some of the benefits of Industry 4.0. The area where maybe you should wait is in integrated systems. So if you're trying to integrate information flow across your whole enterprise between different business systems, there is some risk in investing in a product now to maybe match up with existing systems versus taking a more holistic approach with technology that's already been integrated. One of the problems that you run into in several of the Manufacturing USA institutes are working on is, in many cases, some of the larger product suppliers in this area, Siemens, for example, they want to sell you a whole line of products of theirs that kind of solve your whole business problem. But if you go down that route, they may not, it may not allow integration of other kind of best-in-class products from smaller vendors. So I think that's really the big challenge when you're thinking about a larger implementation is trying to figure out how these pieces are going to connect together, and then also, how to sustain them over the long term.
Okay, thank you, Mike. We have another question that just came in. Does Industry 4.0 address anything related to traceability?
So Industry 4.0 is about ways to collect information in your process, whether you're doing it automatically through scanners and barcode readers, and some of that technology exists already today, but it's getting that technology out into the process so you can do it more reliably and more extensively. And obviously, if you're collecting that data on the floor throughout your process, then that generates that stream of traceability. So I think in general, the technologies that are being developed and deployed do help with the traceability problem. And, there are existing business systems that also help with that. So I think that is an area, if you're having challenges in that area, that there are technologies that can probably help you today that you can start looking at implementation for.
We have a couple more questions. Mike or Mark, what kinds of resources does a company need to try to get started with Industry 4.0?
That's a difficult question. You really have to look at what capabilities you have inside the company. If you're a smaller company, you probably need to get a industry partner to help you, either a system integrator, or you can contact us, obviously, to identify really what type of pilot project are you looking to do. We can help with that identifications, help you see how it aligns with your business objectives, give you a sense of what a little assessment about what your internal capabilities are, and then maybe recommend different types of resources that are available to help you conduct a pilot program if you were wanted to do it on your own.
Okay, thank you. Another question just came in. How can Industry 4.0 help with communications on the shop floor?
Well, we had the example in the webinar with Rolled, where they had different type of messaging information systems set up that you could contact people's smart devices or things like that. So in general, Industry 4.0 is all about a connected system. So if your operators have a way of communicating, you want that information to be shared at the operator level and even up through managers in that organization, and even provide availability to customers to look into certain things if that's desirable. But yeah, Industry 4.0 does allow for that type of communication.
And if you have an ERP system that's tracking work, or a manufacturing execution system that's tracking work in the process, some of these tools, the communication tools, can be connected to those systems. So you don't have to buy a whole new system, but you can add kind of the communication part into systems that you already have.
Okay, I think we have time for one more question. This one is, are there grants available? What kind of funding is available to help cover the costs of any Industry 4.0 implementation?
So Mark talked a little bit about our program, and our program really, we have funding from New York State to help with the kind of services that we talked about, help you organize your approach, figure out what problems have value, and then evaluate technologies that you may want to implement. There are some additional funds within New York State that can also help with, I'd say, the development side of this. In terms of funding for new software or new hardware, I'm less familiar with those programs, but I know that the MEPs do help companies identify resources for these kind of systems, and that would be a good place to start in terms of trying to find out what kind of resources can help with hardware and software.
And MEP stands for Manufacturing Extension Partner.
Great. We did have a follow-up question. The follow-up was, how will this impact companies that need to have secure systems due to government compliances?
So cybersecurity is a major component of Industry 4.0, and the national manufacturing institutes that are working on developing these technologies, the Smart Manufacturing Institute and the Digital Manufacturing Institute, are working on trying to understand what some of the risks and how to offset those risks are. Some people are concerned about cloud and getting things off facility, but there are very high security cloud-based systems that even meet defense type security requirements. So there are challenges here. If cyber is a concern as you start thinking about some of these kind of systems, there's another resource in New York State through the Manufacturing Extension Partner in the Mohawk Valley, AIM, and they help companies with both assessments and also implementation. And I think there are a couple of Fuse Hub programs also that provide funding to support this kind of assessment. So it is a challenge that you need to think about, particularly if you do have defense work that you're addressing. But within the larger community that we've been involved in through the Manufacturing Extension, through the Manufacturing USA Institutes, many of the players there are Lockheed Martin and Boeing and people that have the same kind of requirements you do. So these solutions are evolving, and I think if it's a very important part of your business, getting engaged in that community is helpful. And actually, it's not too timely. There's a workshop at the Digital Manufacturing Institute tomorrow, I believe, on cybersecurity for small and medium-sized companies. But there will be more of these things coming out, and there are resources there to help with these problems. And both the Department of Defense and the Department of Energy have put significant, or are putting significant resources into that issue.
Thank you, Mark and Mike. Thank you all for joining us today, and thank you so much for submitting all of your questions. We're happy to see that, Industry 4.0 is resonating with so many of you. If there's a question that you wanted to ask but really didn't get the chance, please feel free to type that into the question section. Mark and Mike will be answering questions in our follow-up email, and we'll be sending that out to everyone later on this afternoon. As a reminder, if you missed any part of today's webinar, or maybe you just wanted to revisit a particular segment and listen to it again, a replay of today's webinar will be immediately available to all registrants and attendees. So please be on the lookout for that email. Make sure you check your spam and your junk folders as well. Again, thank you very much for attending today, and I hope you all have a wonderful day.